Welcome back, viewers. This is the next part of the ongoing virtualization CBTs I'm making for you. Currently we are covering XEN for past few video segments. Today's video is in continuation to that. If you recall, in the last video we created a virtual machine on an LVM slice, and we closed our discussion at that point. Today we are going to cover a few different things, and one is similar, rather one is in relation to LVM, which is cloning a virtual machine using both file-based and LVM-based backends, copying data to and from LVM, and running file system checks on an LVM. Few of these topics which I am narrating to you might sound a bit advanced. However, I found it in line with the way we are covering this course or this training. Then we will move on to installation of Windows Vista and Windows Windows 2003. Where is that? Okay. And Windows XP and installation of para-virtual drivers on Windows XP 2000, 2003, etc. Come on, 2003. Alright. Fine. So before I start, I want to recap a little bit for all my viewers that what are we using at the moment. Let me show you very clearly what I'm using right now. I'm using CentOS 5.4. my kernel is 64-bit, and I'm running it on 64-bit machine, and I have updated my kernel using simple yum update kernel command already. Before I started off with these videos, before I started off with first video, I had already done this. And what else? Okay, version of XEN, I have rpm -q XEN. I have XEN 3.03, and this is the latest updated one, which comes with CentOS. Nothing extraordinary, nothing from source code at the moment, nothing from any other extra repository. Everything which comes default with Red Hat, CentOS 5.4 to be precise. I'm using that. Just yum update, that's all. And let's check for libvirtual and QEMU. So these are the versions I'm using, and these are the ones which are available to my CentOS 5.4 distribution. Okay, so this is a brief recap. This system has 1.5 GB of RAM, and that should be enough. It's dual core. Alright, so let me show you how do we clone a VM. It's very interesting, and once I minimize this, you'll probably be surprised to see all these virtual machines here, because in the last video they were not here. What I've done is while you were away and while I was working on this thing, I created these virtual machines. I tested various things. I installed Windows 2000 to further install para-virtual drivers on it, but the GPL para-virtual drivers do not support Windows 2000 anymore, and Windows 2003 I yet have to experiment with the drivers. Windows XP and Windows XP no APIC. Basically, I want to show you that how should you install any Windows version on any modern day computer you have, and what is the significance of APIC and no APIC. We'll be covering that shortly. First of all, let me show you this para virtual machine CentOS. Let's start this machine. and let's once it starts, okay, let me just log in, root, Red Hat. Okay, this is one of my machines which I've created on ParaVirtual as a PVM, and you can confirm that by using uname -r. It's running 2.6.18-164 .el5 Xen. If you see Xen here, that means it's a domain U running running as a ParaVirtual machine. Fine, and it has this IP 192.168.122.129 here. Okay, never mind. It doesn't have a host name right now, which is not important to us. Pardon me, I have bad throat again. Okay, let's say that I want to create a file here. Remember that this ParaVirtual machine is created on an LVM, which is further partitioned from inside into two partitions, XVDA1, which is the root Linux partition, and which is bootable as well, and XVDA2, which is small swap partition, which I created, and it's a 3 GB virtual disk which we have assigned to it. Let's create a file. Let's say important stuff.txt, and that's all. I saved and exit, and this file looks like the following: important stuff.txt. Why I created this? Because I'm going to show you how you are going to replicate an LVM and how you're going to back up data from it, etc. It's very efficient method to back up your virtual machine without disturbing it. Alright, so while my machine runs, what I will do is, it's still running, right? So what I'll do is minimize this, go to my text prompt, and I will create a snapshot of it. First of all, I want to see what all LV logical volumes I've got. So I will do LV scan, and I get all these logical volumes. If you recall, this is the one we created in the last video, and these three I have created while you guys were away. Right, so I'm going to replicate this one, and I'm going to take my help from my command text file which I created on my host computer here, because I'm lazy. So this is the command I'm going to use here. I'll just put it here so I can see it. Okay, so if I do lv create -- snapshot of this new name, it's going to be Linux disk, or let's have the same name, Linux VM1 disk, and add the word snapshot 1 to it. And what I'm going to snapshot is /dev. Let me expand this window for you. I'm going to take snapshot of this device. Okay, so I press click here and press enter, and it gives you an error that please specify size or extents, but not both. I purposely typed this command to show you that it will not create a snapshot out of this image, this LVM, if you do not provide a size. So we see a size here that this LVM host source LVM is 2.88 GB in size. So I'm going to say lv create -- size, and I'm going to say 2.9 GB. Okay, this must be enough. I can even use 3 GB to be on the safe side. Okay, so I press enter, and if you want to be verbose, I'll just type -v here. I'll repeat the command again for you. LV create -verbose -size 2.9 GB, which is almost the same size. It can be larger, it can even be smaller, but then you should have an idea that how much space actually is used inside that snapshot in the actual source LVM, this one. Then you specify the keyword snapshot. If you miss this, Linux will create a separate LVM with this name here. With this name, it will be created as separate LVM if you miss the keyword snapshot. If you provide it, it will create a snapshot or a mirror image of this disk, this LVM, and will create this LVM snapshot out of this source LVM. Okay, so press enter now. It's creating this snapshot, and the 3 GB snapshot is created in about 5 seconds, wasn't it? Right, great. So how do I check that? LV scan is the friend, and here I see this original LVM of this much size and I see a snapshot here, right? And it took only 5 seconds to create a 3 GB kind of mirror. Okay, there is a reason to it. It uses a copy on write technique, but the main point is my host machine remained online. Okay, I'll show you here. My host machine, which I was taking a snapshot of, remained online, didn't get hurt, and I still took the snapshot of its disk. Right. Okay, let me create a VM out of it. That's interesting stuff. etc. Let's go to etc XEN, where all the virtual machines and configurations are held, and list and copy pvm CentOS LVM as pvm CentOS LVM snapshot. Okay, snapshot 1, let's say. So what you have essentially done is, let me remove this file for you before I continue. Okay, list of files is like this. I've created a copy of this file as this file. Okay, I'm going to edit pvm CentOS -snapshot1. This is the config file of a new virtual machine. I'm going to name it as snapshot. This is going to be the name of the VM. I'm going to remove the UUID because it will conflict with the present UUID. Okay. I can even reduce the RAM to 384 if I want to, and I'm going to remove this MAC address because it will also create a conflict. And most important, I'm going to remove this I'm going to edit this dev disk store Linux VM1 disk. I'm going to provide, let me open another terminal here, su minus lv scan. Okay, I'm going to provide mention that this is going to be the disk. This snapshot which I just took is going to be the disk for my new VM. Okay, sorry, like this. Now let me explain what I've done. Essentially, I've created a copy of the disk of my actual virtual machine number 1, call it number 1. I've created a copy of its configuration file. Alright, then I've modified the configuration file to change the name, remove the UUID because it will be generated on the fly, optionally change the RAM because I want to save a bit of RAM. It's not important, not required. I have updated the physical device which it will access with this name, the snapshot, and I've removed the MAC address. Okay, so I'm going to save this, and I'm going to check if this shows up here. It does not. Okay, right now it does not show up here, and we'll cover that later. Right now my virtual machine is ready to be powered on. I already have my source virtual machine powered on here. You can see it here, and you can see it on the virtual machine monitor here. It says running. Excuse me. Alright, so the command line equivalent to start a machine is XM create and PVM CentOS LVM snapshot 1. Okay, and see it boot. Press enter. It should say domain created. Come on, started domain. Okay, and it shows up here, and I double click and I see the machine is booting. Okay, I'll show you interesting stuff here. Okay, let's do full screen for this machine. It's trying to get IP on DHCP. Okay, done. Okay, root, Red Hat, great. And if you type ls, surprisingly you've got your file here. See, means it's not, it shouldn't be surprise for you. It was a copy of that LVM, and if you cat this file, cat important stuff, and it's there. Fine. So you get the idea. How can you create a copy of a virtual machine immediately, almost immediately, with the help of LVM? Now let's shut this down. I'm going to show you another interesting stuff. Okay, init 0, and you see this virtual machine manager. Both machines are running. This one is shutting down. The one which is highlighted, dead. Alright, shut off, and it's gone from here as well because it was not created from the GUI. Alright, this machine is dead now. Why we bothered this much that created a VM out of it? Well, this is an excellent mechanism if you want to back up your system. Let's say back up your virtual machine. What you've done is you created a copy of its LVM, right? This one's still running. Remember this, I showed you this machine here, it's running, still online. So, but you have made a copy of its disk, exact copy here. So what you can do now is you can mount this on your physical host here and get the data, whatever data from it, and save it elsewhere. Now the next few minutes are going to be a bit advanced for many viewers. I don't know if you should, just don't get confused. I'm trying to I will try to be as simple as possible. First I'll define the objective. The objective is to extract certain pieces of data out of this virtual disk which we have copied from the first para-virtual machine. Okay. To do so, we must have the virtual machine using this LVM shut down. In fact, there was no need to create an LVM. In fact, there was no need to create a virtual machine to use this disk and boot off. There was no need, which I did here on the step above here. There was no need. I just showed you that this can be used to replicate virtual machines. Now that objective achieved, we move on to making backups. So assuming this LVM is attached to a particular virtual machine, we copied its LVM here as a snapshot. What are we going to do next? Next is we will treat this as a disk. First of all, this is important to understand. We have to treat this device LVM as disk, because you know that when we provide this LVM, either this one or this one, it's presented as a disk to the virtual machine, and virtual machine creates partitions inside it. So this is in fact, either this one or this one is in fact a disk, virtual disk. It has partitions inside. So with that said, what I cannot do with it is, let's say /mount/LVM. I cannot mount something like this, that /mount/ dev/ whatever to /mount/ loop. No, because it's a disk with further partitions in it. You cannot mount it on loop back. So what's the solution? The solution is simple, and I'll provide you as simple steps as I can. First, I'm going to clear the screen to remove the clutter, and I'm going to repeat a couple of steps. LV scan, these are my LVMs, and I'm going to create I'm not going to create anything right now. Let's run a utility known as KPartX. It's available in every modern day Linux distribution. Let's check its help. Okay, if I do KPartX minus add device mapping, add partition device mapping here, or I can check it with L first, list partition dev mapping, that would be added by -a. Now K partition X minus list what? List of this disk, so called, although it's an LVM, it's presented as a disk. Okay, press enter, and it tells me that there are two partitions inside this disk which would be mapped if I use -a. A simple -l doesn't harm anything. So it has listed me that there is one, see, partition 1 and partition 2, and from here onward this is the name of the LVM we are talking about, like this one. So partition 1 and partition 2, this one seems to be larger in size, this one seems to be smaller in size. Is it? Seems so. So what I can do now is I can also do -v to verbose listing, nothing much difference. So what I'm going to do is I'm going to check actually map these partitions, KPartX -a, and map the partitions inside this disk. Press enter. Done. But where are the partitions? Good question. You do ls of /dev/mapper. That will show you all the disks which are mounted and which have partitions in it. So you see that your snapshot 1 is showing here as cow. It's not that cow which provides you milk. This means copy on write. Okay, and this is your disk snapshot 1 partition 1. Your disk or same LVM snapshot 1 partition 2, right? So these two are now mounted as proper partitions. How do I access them? You create some mount points, let's say /mnt/ snapshot 1. This would be very long, so let's say partition 1, okay, and partition 2. Great. Remember, we are on the physical host. I created two mount points where I'm going to mount this /dev/mapper/ partition 1 to /mount/ partition 1. Simple. And if I simple do a mount, it will show me that this thing is mounted on this mount point with type extended 3. Oh, it automatically picked up that what partition it is. Okay, before I show you the interesting stuff, let's mount the second partition as well, and you'll find some surprise. Well, it's not a surprise actually. Okay, so mount dev mapper Linux VM1 disk snapshot 1 partition 2 to /mount/ partition 2. Press enter. Great. It looks like swap space, so not mounted. That's what it is. It's swap space, and we don't need to mount swap space, right? We don't have anything inside it. So we will limit ourselves to simple mount command will list the currently mounted devices. We will limit our discussion to this one. So I change directory to /mount/ partition 1, and I see, I see the root file system or the directory layout of my LVM, or the root partition of the LVM. If I go into not /root, if I go into root from at this level and I do a list, I see my file here. See, get important stuff. Great. So if I do df-h, I see that this partition itself was of 2 GB in size. Remember, the disk, the whole disk, this one till here is 3 GB in size, 2.9. But partition 1 is 2 GB in size and is used only less than 1 GB, 51%. It's showing everything which is there inside this partition, just like a regular disk partition. Everything is just the same. Okay, so what's the purpose behind doing all this? We have mapped the partitions with KPartX. We have mounted the partitions, or at least the partition, at least one partition. We saw that there's our data inside it. Now what I can do is I can, let's say, I want to back up the home directories from it, and for some reason the virtual machine was not booting. So I can mount the /home. I can copy the /home, tar, create compress file. I'm going to create it in /temp of my physical host. I'm going to create it as VM home .tar.gz, and I'm going to include home directory at this level here. Press enter. Great. And if I want to make a backup of all the configuration files, I can do like this. Let's add V as well for your peace of mind. Okay, so if I press enter now, you will see backup being, or at least a tarball being made out of the etc directory of this, of the etc directory at this level, mount P1. Now I go to /temp of my host, physical host, list the files, and I see my home tar.gz, I see my VM etc tar.gz. See, so you can use this technique of mounting an LVM using KPartX and then extract the data out of it. This is exactly what I am doing with many of the virtual machines which I am managing elsewhere at different physical servers, that copying the physical disk, if it's a file based VM, is very, very problematic. I'll show you in a moment why it's problematic. So, but copying a VM, making a snapshot out of it and then extracting data out of it like this method doesn't have any effect on the virtual machine. See here, it's sleeping just like before. No activity here on this PVM. Nothing is happening to it. It's just working fine. It's still staying here. Alright. So, with that said, let's do one more thing. Assuming you have already copied the data back, copied data, now you can also copy some data inside it. Let's say copy /root/ what do I copy? I copy this is difficult at times. Okay, let's copy iSCSI target to /mount P1 root. Okay, this directory doesn't have iSCSI target, so I just copy it here. Done. You all agree? Okay, and it's mounted. Done. Okay, so now you umount /mount/P1. Remember, never ever, let me scan, LV scan, never ever mount a logical volume which is being used by a virtual machine like this one right now. This virtual machine here, is currently running. So its LVM is also mounted with this virtual machine. This is its LVM. Do not mount it on the host system. It will corrupt the disk. Always make a snapshot like this and play around with it, whatever you want to do with it. Okay, what I was going to show you is I have copied some data inside this LVM partition and I've unmounted it here. It should not show me anything mounted here. Yeah, it's gone from here. Right. Now, if I go to etc XEN, I still have my this second virtual machine which was copy of this one. I can run it, sim create this one, and come on. Okay, started. I go here, I check the screen, it's booting. The file which I copied in /root in the LVM should now be present here inside this machine. This is what I want to show you. By the way, this method is also usable if you want to experiment with something with your VM. I'll just explain. Let's close one topic first. ls -l see here, this is the file which I copied from the physical host inside this. Okay, this is not the only method. Of course, I could have used SCP to copy whatever data from whatever IP, but I showed you the power that how you can use LVM, mount it and move data back and forth and unmount it and again mount it and use it with your VM again. Okay, the next advantage of using this mechanism is you want to test something on your VM. What you can do is shut down your actual VM, not this one. This, assume this does not exist. I'm shutting it down. This is secondary VM. I'm going to delete it as well to keep things simple. Okay, view full screen, undo, and it's closing down. Let's close its screen. It will show up here dead. Okay, it's gone. I am going to remove this PVM snapshot file. This is the config file, not the LVM snapshot. Okay, it's gone. This was virtual machine configuration. It's gone from here. Now here's what I'm trying to explain, how you can use LVMs or these snapshots. Assuming this was your physical machine, it's running here, see? Okay. You want to test something very drastic on it, but you don't want to go that you don't want that if something goes bad, you don't want to reinstall it, right? So what you can do is ideally shut down this machine, make a snapshot of its LVM just like this as we have here right now, LV scan. Make a snapshot of its original disk as this one, then edit the virtual machine config file and provide the name of snapshot here, snapshot 1 LVM here, and then save it and then boot the system. So what essentially would happen is, since my machine is running, I have not saved it. What would happen is that your same VM, this one, which would be shut down at that time, would boot from this LVM, from this disk, and it would see that no changes have occurred. It would boot normally. It would work perfectly similar because it was exactly the copy. You perform whatever experiment you wanted to perform on this. If it failed, never mind. Shut down the machine, drop the snapshot, edit the config file, this one, and put the disk original LVM back, reboot the machine. That's all. Reboot the virtual machine. That's all. Got my point? So this way you can experiment with certain piece of software. If it messes up your disk, drop the snapshot again, go back to your original disk, boot the system, do whatever, or even you don't need to reboot your system again and again. Make a snapshot, run the system, do your experiment. If it fails, shut down the machine, remove the snapshot, recreate the snapshot from the source disk without rebooting the system, recreate from the same source again with another name or maybe the same name of the snapshot, and again boot the system. Again start your experiment with change of parameters, and keep doing this, keep having fun as long as you want. So this was a brief introduction of how you can play around with LVMs. Now I'm not done here. I still want to show you one more trick. Remember that KPartX, we added partitions with it. We still have our partitions showing in dev mapper here, these two partitions, but they are unmounted. They are unmounted. So interestingly, we can run e2fsck on /dev/mapper /Linux snapshot1 partition 1. Remember, do not run fsck on any partition which is mounted. It will corrupt the partition for sure. Press enter. Lovely, it shows that it's clean. It treated this snapshot exactly as a partition, ran the fsck test exactly as it would run on a partition, and even fix anything if it is wrong. And that's great. So you can, if you ever mess up with any of your virtual machine and it's critical it's critical value to you, key value to you, you shut down the machine, mount its LVM. Sorry, don't mount its LVM. You can either run e2fs directly on its LVM or make a snapshot of it and run an fsck on it, find if there's a problem, fix it, and there you go. Mount it again, try booting off again. There are lots and lots of tricks you can play around like this. It's really fun. It's really fun. Okay, so now we are even done with fsck test with this partition which we mapped. So I assume that the task is finished or objective is achieved. So now I'm going to remove it from KPartX interface, KPartX -- help, and I'm going to delete. It will not delete the partition itself, it will just delete the maps. Delete /dev/mapper not /dev/dev/disk store Linux VM disk snapshot1. Yes, that is what it is going to be. KPartition X, delete mapping for this LVM. Okay, these two here were partitions inside this LVM. We cannot delete the map directly, we have to delete the map of our device. So in this case this is an LVM, the parent LVM. So you can do a -v as well if you want to. Press enter. See, dev map is deleted, and once you do an ls of dev mapper like this, see, press enter. These two are gone. This one is gone, you will not find it in the list here, and this one is gone, you will not find it in the list here. Okay, and in LV scan you still see your snapshot because we did not delete the snapshot itself. Now if you are done with this snapshot, done playing with it, you can also delete this snapshot with the command LV remove, and I always forget the command, so LV remove -verbose to be okay, logical volume path is going to be this one. I'm going to remove this logical volume. Press enter. Yes, I want to remove active logical volume. Yes. Okay, done. Logical volume, this one successfully removed. If you do an LV scan now, there you go. The snapshot of this VM is now gone from here. Okay, it's no more here. Okay, so that's it. You saw how you can how you can create a snapshot out of an LVM, how you can create a new virtual machine, assign that snapshot to that new virtual machine, boot that virtual machine, play around, shut it down, play with its partition on the low level on the physical host, check partitions, format partitions, even you can do that, and unmount partitions. You saw how you used KPartX, etc. Okay, just to give you one more and one last example and idea of why LVM is so cool, so good. Let's say I'm going to copy this vServer. This is a file based LVM. I'm going to show you. Cat vServer, because I'm already inside this directory where the configurations of virtual machines are held. See, this is tab AIO, various libs and images, vServer image. This is a file. What is the size of this file? This one, 4 GB. No, 3 GB. Snapshot took 5 seconds, under 5 seconds. vServer right now, this is a machine, virtual machine, is shut down. Oh, sorry, is right now it's shut off. Okay, so its disk is not being used. This is important. All right. So what I'm going to do is, let me check how much disk space I have. I have plenty of disk space in slash. So what I'm going to do is slash various lib XEN images. Okay, here, this is my file. I'm going to show you why LVM are better, why file based systems are not good. Although for simplest systems, they are the way to go for all the experiments and for the beginner level. But let's make a copy of it. Okay, dd if is equal to input file is equal to vServer dot image, output file is equal to slash temp slash vServer dash tmp dot img. Okay, and just sleep over it because it will take a lot of time. While it does its task, let me explain one more thing. That since this is also a disk, a complete disk with different partitions inside, you can also mount this image with KPartX and play around with its data. I'll just show you an example. Let it complete because I want to play. I want to show. I want to show you whatever I'm going to do with it on the working copy of this image file. Okay, come on. 5 seconds have definitely passed. Still not done. I believe 10 seconds are also passed. And the disk I/O would also have shot up. Let's see, the load would have gone up. See, dd is consuming about 38% of CPU. This dd command, and the load is going up 1.29. I once accessed a server for some repairs or maintenance, and it was file-based virtual machine. I had to add, guess what, an 80 GB of file, 80 GB of disk as file, and the load on the physical host, it shot up to 136, and it took probably 1 hour. I don't remember exactly, creating the disk file 80 GB on the host file system. It was a nightmare. But anyway, that's done. Oh, this is definitely not advised for production systems. You see how much time it's taking, then you have to mount it, and of course you cannot afford to shut down the production server. You noticed that I took a snapshot of the live running virtual machine. In this case, I can do that as well, but it will slow that system down a lot for all these number of minutes, X number of minutes it's working, and that would have a negative effect on the productivity and the availability of that virtual machine. Where is virtual machine monitor? Okay, you see domain 0 itself, this storage is domain 0, of course. It's consuming around 33% of CPU. Come on. Load is 1.96. I can show you that if you go in /temp, oh, it's almost done. Done. So it took 218 seconds. Okay, I'm not very good at maths, let me tell you, so I can run the command kcalc and cancel that. Okay, I can paste it here, divided by 60, and it cost me 3.6 minutes instead of 5-6 seconds. Okay, fine. So this disk is copied. Let's go to /temp. Alright, again, you cannot directly mount it because it's a full disk with partitions inside. You cannot mount it like this, but I'm still going to show you. See, what I'm going to do is I'm going to use the KPartX utility, and I'm going to list what's available in vServer. Oh, Verser. Oh, damn. What is this spelling? Sorry. Okay, it shows me that it has 2 partitions which can be used. Now I can add this mapping, and I can check dev mapper, and I have this loop p1 and loop p2. Okay, and this one seems to be bigger and this one seems to be smaller apparently. What I can do is I can use the same p1 p2 list, empty p1 is empty, p2 is also empty, so I can reuse these. I can do /dev/mount/dev/mapper and loop p1 to /mount/p1. Mount it. List of /mount/p1. Great, it's the root file system, root disk, root directory of that virtual machine vServer. And again, you can do whatever you want to, copy data back and forth. umount/mount/p1. Try doing it with p2, and you will probably get an error that's swap space. Fine, it's not mounted. Check it with mount. It's not mounted. Lovely. So since it's not mounted but still mapped in dev mapper, you can run the fsck test if you want to. Okay, e2 fsck on /dev/mapper/loop p1. Okay, it's clean. Great. And once I'm done playing with it, I can do KPartX minus delete. Delete what? Delete this one. Loop deleted. So this should not exist anymore in mapper directory. List/dev mapper does not exist. Okay, it's gone. Loop 0 is deleted. Remember, dev loop 0. And partitions were, let me show you here, partitions were loop 0 p1 and loop 0 p2. So since loop 0 is gone, of course its partitions are also gone. So this topic, let's close this, conclude this. I started it off with LVM, snapshotting and the benefits and how to do it, and it later entered into a bit advanced parts such as usage of KPartX, mounting LVMs, copying data back and forth. If you do not understand this at this moment, it's not important. You can review the other videos, practice with the other videos, and then when you feel it's right, you can again review this video and again experiment with whatever was shown here, and that will help you understand the ideas and the concepts. Right, so that's all. I close this segment now, and I deal with Windows specific things in the next video segment. So bye for now. Thank you for watching.